Hello. Welcome to my channel. Let's solve some exercises on ellipses. We start with a very simple exercise. Given the points P1 of coordinates 0, 3, and the point P2 of coordinates 4, 2, we want to calculate the equation of the ellipse of center at the origin that passes through the points P1 and P2. We know that the equation of an ellipse with center at the origin is the canonical equation x squared over a squared plus y squared over b squared equals 1. We substitute the coordinates of the 2 points in place of x and y in the equation of the ellipse, and we get a system of 2 equations in 2 unknowns that are a and b. Then we solve the system and we get the 2 values of a and b, and accordingly the equation of the ellipse we are looking for. Substituting the coordinates of P1, we obtain 9 over b squared equals 1, while the other point yields 16 over a squared plus 4 over b squared equals 1. From the first equation, we know that b squared equals 9. Therefore b equals 3. Remember that b is the length of the semiaxis parallel to the y-axis. Therefore it is a positive number. Then we insert this value into the second equation, and we get 16 over a squared plus 4 divided by 9 equals 1. This means that 16 over a squared equals 5/9. Therefore a squared over 16 equals 9/5. We get a squared equals 144 over 5. And a equals 12 over square root of 5. So we have found the equation of our ellipse. That 5 over 144 times x squared plus y squared over 9 equals 1. In figure you can see the graph of the ellipse that passes through the points P1 and P2. In the second exercise we have a circle and an ellipse, arranged like in figure, that have the same center. Knowing the equation of the circle, that is x minus 3 squared plus y minus 2 squared equals 16, and that the eccentricity of the ellipse is 0.8, we want to calculate the equation of the ellipse. Let's get started. Firstly, we know the coordinates of the center of the 2 figures from the equation of the circle. In fact, the canonical equation of a circle is x minus xc squared plus y minus yc squared equals r squared. In our case xc equals 3 and yc equals 2. So the center has coordinates 3, 2. The ellipse is internally tangent to the circle at 2 different points that are 2 vertices of the ellipse. In particular the 2 vertices V1 and V2, formed by the intersection between the major axis and the ellipse. This implies that the major axis of the ellipse is congruent to the diameter of the circle. So the semiaxis is congruent to the radius. Therefore r equals 4. At this point we know the coordinates of the center of the ellipse, and we know the value of a, the length of the semiaxis parallel to the x-axis. We miss only one thing. That is b, the length of the semiaxis parallel to the y-axis. The information about the eccentricity will help us to find the value of b. The eccentricity is given by the ratio between c and a, where c is the distance of the 2 foci from the center of the ellipse. This distance in our case is equal to square root of a squared minus b squared, being a the semi-major axis, and b the semi-minor axis. So the eccentricity, that is worth 0.8, or 4/5 as a fraction, is equal to square root of a squared minus b squared over a. So a squared minus b squared equals 16/25 a squared. Therefore b squared equals 9/25 a squared, and b equals 3/5 a, being a equals 4, b equals 12/5. Once we have found the value of b, We have all the elements necessary to write the equation of the ellipse. It is x minus 3 squared over 16 plus 25 144 times y minus 2 squared equals 1. In the last exercise, we have a circle with center at the point of coordinates 4, 0 and radius equals 3. We want to find the equation of the ellipse with center at the origin and tangent to the straight line y equals minus 1/2 times x plus 5. At the midpoint of the chord AB of the circle determined by the line itself. We are looking for the ellipse tangent to the point M in figure. We need to find the coordinates of M. So first of all, we have to find the coordinates of the 2 points A and B that determine the chord of the circle. We make a system with the equation of the circle and the equation of the line. The equation of the circle is x minus 4 squared plus y squared equals 9. We insert the value of y into the first equation, and we get x minus 4 squared plus 5 minus 1/2 x squared equals 9. We solve the binomial square, and we obtain 5/4 times x squared minus 13 times x plus 32 equals 0. This equation has two solutions. x1 equals 32/5 and x2 equals 4. From the equation of the straight line, we get the two corresponding values of y. y1 equals minus 1/2 times 32/5 plus 5. That is 9/5. y2 equals minus 4/2 plus 5. That is 3. We have found the coordinates of A and B, the 2 points of intersection between the line and the circle. Now we calculate the coordinate of the midpoint of the chord AB. The abscissa of the midpoint, xm, is equal to xa plus xb over 2, and it's worth 26/5. The ordinate ym is equal to ya plus yb over 2, and it's worth 12/5. We have finally found the coordinates of the point M. In order to find the equation of the ellipse tangent to the straight line at the point M, we make a system with the equation of the line and the equation of a generic ellipse with center at the origin. It is x squared over a squared plus y squared over b squared equals 1. Then we insert the expression of y into the equation of the ellipse, obtaining x squared over a squared plus 5 minus 1/2 x squared over b squared equals 1. We construct a single fraction with the least common multiple as a denominator, and then we solve the binomial square. We get a second-degree equation in x with two unknown parameters, a and b. We have two conditions to find these parameters. The first is the condition of tangency. So the discriminant of the equation must be null. And then we want the ellipse to be tangent at the point M. Therefore the solution of the equation must be equal to the abscissa of the point M. Let's start from the condition of tangency. The discriminant of the equation is 25 times a to the 4th minus 4b squared plus 1/4 a squared times 25a squared minus a squared times b squared. We multiply the terms in brackets. Then we can see that the two terms a to the 4th cancel each other out. We get 4 times a squared b to the 4th plus a to the 4th b squared minus 100 times a squared b squared equals 0. We factor out a squared b squared, and it is multiplied by 4 times b squared plus a squared minus 100. So 4 times b squared plus a squared equals 100. Therefore a squared equals 100 minus 4 times b squared. Now we have to find the solution of the second-degree equation in x. Being the discriminant null, the equation has only one solution. If we call alpha the coefficient of the x squared term, beta the coefficient of the x term, and gamma the constant term. The equation becomes alpha times x squared plus beta times x plus gamma equals 0. The quadratic formula for this equation is minus beta plus minus square root of beta squared minus 4 times alpha gamma, all over 2 times alpha. The discriminant of the equation is null. Therefore the term under the square root is 0. And the solution becomes xm equals minus beta over 2 times alpha, where xm is the abscissa of the point m. That is worth 26/5. We substitute the two expressions for beta and alpha, and we get 26 divided by 5 equals 5a squared over 2 times b squared plus 1/4 a squared. The framed equation, derived from the condition of tangency, can be used to get an equation with the single variable b. We put 100 minus 4 times b squared in place of a squared. And with some calculations we get 26 divided by 5 equals 500 minus 20b squared over 50. So we have 260 equals 500 minus 20 times b squared. Therefore 20 times b squared equals 240. And b squared equals 12. A squared is equal to 100 minus 4 times b squared. Therefore 100 minus 48. That is 52. We have finally calculated the value of a squared and b squared. And we can write the equation of the ellipse tangent to the chord AB at the point M. It is x squared over 52 plus y squared over 12 equals 1. We can draw the ellipse in the Cartesian plane. An ellipse with the semi-major axis A equals square root of 52. That is worth about 7.21. And the semi-minor axis B equals square root of 12. That is worth about 3.46. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.